If you are live or not so that I can start the session. Okay. So hey, hi, hello everyone. Welcome to the session. So this is Manisha, your class 9 chemistry educator. And today we are going to start introduction to soft and hard water, a very important topic from the chapter water. So all of you please keep joining and do not forget to share and like this session. Very good evening, Piyush. Very good evening. Welcome to the session. Okay. So this is Manisha and these are my credentials and I have 6 years of teaching experience. So you can join me on Telegram using this link. You can even join the Telegram channel of your Unacademy for latest notifications and all the news. So okay. So you can join now my class 9 exam is over. Okay Piyush, your class 9 exam is over. Okay. So how was your exam? Good? Everything means went nice. Every exam was good. Okay. So you can join me on Unacademy free special classes also. These are absolutely for free and you can unlock all the special classes by using my code Manisha Live. Okay. So you can just download the app 10th class chemistry. Piyush, this is again your class 9 chemistry only water chapter, that is introduction to soft and hard water. Okay. So your class 10 chemistry will be at 9 p.m. in the night, but today we don't have any classes for class 10, means for chemistry. Okay, yes, it was very easy, but अच्छा ही लिखा है. Okay, अच्छा, चल. So your free special classes I just told you is absolutely for free. You just have to download the app, Unacademy app, follow all the instructions and enter my code Manisha Live and you can unlock all my free special classes and watch them. Okay. You can even ask questions in the free special classes. You have live poll options, poll leaderboard, everything you can have. Okay, and this is the special class timetables on 7th at 5:15. So my special classes for class 9 starts at 5:15 p.m. in the evening. Okay, so at 5:15 means on 7th you have this power pack revision on hydrogen. So you can join join this class. Okay, and if you want to take the Unacademy subscription, that is also very easy. You can take that on with subscription. You can learn live from the comfort of your home. You can have unlimited access to all the courses. Top educators of India are teaching on this platform. Okay. Okay, Piyush. Sure. Chalo. So do share this session with all your juniors who are in class 8 and now moving on to class 9. Okay, so that they can attend this session and have a general idea like what is soft water and what is hard water. Okay. Regular doubt solving sessions we have, exhaustive coverage of syllabus we have with Unacademy subscription. So many more things are there which you can take with single subscription, and if you take subscription for class 9 you get 10, 11 and 12 subscription for absolutely free. Okay, and you can use my code Manisha Live to get 10% discount. Okay, 10% discount भी मिलेगा if you use this code. Clear? So do take the subscription and let's meet in the plus classes. Okay, and if you do not want to take the subscription, if you are not sure about taking the subscription, you can simply download the app, watch all the special classes and then make your mind if you have to take the subscription or not. Okay, so let's start with the hard and soft water. Clear? So what do you mean by hard water and soft water? So basically your hardness is of two types. Okay, okay. So your water has hard water also and your soft water also. So the water where your naturally present minerals like magnesium and calcium are present in a detectable amount, the amount where you can detect them is known as hard water. Okay, so what is the property of your hard water? That it does not lather, it does not form foam with the soap. Okay, and forms a precipitate that is known by the name of scum, that we will study in a few minutes. Clear? So your water can be hard or soft in nature. Now again, what is hard water? Water which is containing your minerals like magnesium and calcium in detectable amount, that is your hard water. Hard water will not form any lather with the soap and will form a precipitate. Okay. What is now soft water? So soft water is treated water in which only ion is your sodium. Okay. The only ion present in your soft water is sodium, and as the rainwater falls, it is naturally soft. Your rainwater contains no calcium ions, no magnesium ions, no salts of calcium and magnesium. So it's basically your soft in nature. Clear? It's naturally soft. Is it clear, everyone? Please let me know. Okay. Chalo. So this is the introduction of your hard and soft water. Clear? Now, how many types of hardness we have? As I told you, your hardness can be classified into two types. That is your temporary hardness and permanent hardness. Okay. So what happens? Why your water becomes hard? Okay. Why the hardness in water can be observed over here? So let me tell you, when your water moves from like river and all, so some rivers, whales and all, they contain dissolved mineral. Okay. And when the water flows through them, the water takes away the mineral with it and becomes hard. Okay. The water takes the hydrogen carbonates, sulfates or chlorides of calcium and magnesium and becomes hard. So the hardness of water is due to the presence of what? It is due to the presence of your hydrogen carbonates, okay, that is HCO3 minus, your sulfates SO4 2 minus, and your chlorides, that is Cl minus of calcium and your magnesium. Okay, so if these salts of calcium and magnesium is present in water, your water will be termed as hard water. Clear? Now, as I told you, the hardness is classified as two types: temporary hardness and permanent hardness. So your hard water will contain bicarbonates, chlorides or sulfates of calcium or magnesium, which it takes away from the rivers, springs or wells from which your water is taken out, because sometimes your water contains the dissolved mineral matter. Clear? So this is the all about your hardness, temporary and your permanent hardness. Clear? So let's talk about how can we identify which one is your temporary hardness, which one is your permanent hardness. Let's talk about that. Okay. So temporary hardness is that type of water hardness that is caused by the presence of your dissolved bicarbonate. Okay. So if you have like dissolved bicarbonate present in the water, that water will be your temporary hard. For example, if you have like calcium bicarbonate, okay, or your magnesium bicarbonate, okay, so if these two are present in water, then that water is temporary hard. Clear? So why are we calling this temporary hard? Because the hardness of the water can be removed just by boiling the water. If you just boil the water, your hardness can be removed. That's why the hardness is termed as your temporary hardness, that is due to the presence of your bicarbonate salt of your calcium and magnesium. Okay? Is it clear, everyone? Okay. Now next is your, okay, so here you can see calcium hydrogen carbonate, or you can call it as calcium bicarbonate also, same thing. And magnesium hydrogen carbonate, that is magnesium bicarbonate. How do the hardness is removed? How does your hardness is removed? After boiling only. So what happens? Your calcium bicarbonate or magnesium bicarbonate gets decomposed when it is heated. Okay. So if you take like calcium bicarbonate and if you boil it, okay, what we do? If we boil it, what happens? Your carbon dioxide is formed, your water is formed, and your calcium carbonate is formed as a precipitate. Okay, it is formed as a precipitate which is taken out from the water after filtration and water becomes soft. Clear? Because we have removed the calcium salt from it. Similar thing will happen in case of your magnesium also. So magnesium bicarbonate, if you boil it, what happens? Your magnesium carbonate is formed, MgCO3, which comes out as precipitate, your carbon dioxide and your water. Clear? So carbon dioxide your escapes into the atmosphere because it is your gas, and this precipitate is obtained in the water, which can be removed by just filtering out the water, and you will obtain your soft water. Clear? So your calcium and magnesium ions can be removed from the water by the formation of this insoluble calcium carbonate and insoluble your magnesium carbonate. Clear? So you can see when water is boiled, the insoluble carbonates are formed. Okay, insoluble metallic carbonates I should write over here. Insoluble metallic carbonates is formed, which is removed from the water after filtration. Okay, this was all about your temporary hardness and how you can remove it just by boiling. Clear? Next is that okay, when your soluble salts of calcium and magnesium, that is sulfates and chlorides of calcium and magnesium, is present in the water, then it will cause your permanent hardness in the water. Clear? So if soluble salts like your calcium sulfate is present, your magnesium sulfate is present, or you have calcium chloride or magnesium chloride, then because of the presence of these salts of calcium and magnesium, your permanent hardness in the water is caused. Is it clear, everyone? Please let me know once. So is it clear to everyone? Okay. Chalo. So this is all about, so when you have your soluble salts, okay. So if you have your soluble salts, like that is if you have calcium sulfate, if you have magnesium sulfate, if you have calcium chloride, magnesium chloride, so your sulfates and chlorides of calcium and magnesium is responsible for causing permanent hardness. Clear? Why we call it permanent hardness? Because this hardness cannot be removed by your boiling only. Okay, you cannot remove this hardness only by boiling, because calcium sulfate and magnesium sulfate do not precipitate out as the temperature increases, as it was happening in case of your bicarbonates. ठीक है? So bicarbonates में हमने क्या देखा कि it was getting precipitated out in the form of your metallic carbonates, which is not happening in case of your magnesium sulfate or your calcium sulfate or magnesium chloride or calcium chloride, because they do not precipitate out as the temperature will increase. Clear, everyone? So this is known as your permanent hardness. So let me take you to the black screen and let's see what we learned till now. So we have two types of hardness. One is your temporary hardness. Okay, one is your temporary hardness and other is your permanent hardness. Now temporary hardness is caused due to your calcium bicarbonate and magnesium bicarbonate, but permanent hardness is caused due to calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride. This can be removed by boiling. Okay, this can be removed by boiling. How? Calcium bicarbonate, if you boil it, what happens? It gets decomposed to form your calcium carbonate as a precipitate, your water and your carbon dioxide gas. This comes out of water after filtration. After filtration, okay. So this is the there. But here it cannot be removed by boiling. Yes. Why? Because your calcium salts, your sulfate and chloride salts of calcium and magnesium do not precipitate out on boiling. Clear? This is all about your permanent hardness. Now we will also study that this boiling is not a very practical method of removing water. Yes, because it's costly also and it's very slow also. So if you have to remove if you have too much of water and you have to remove hardness from it, you cannot use boiling. Clear? So we have different methods for removal of temporary hardness. But before that, let's see what is the advantages of your hard water. Clear? So your advantages, first advantage is that it tastes better. Okay. So hard water is certainly having a better taste than your soft water. Clear? Your hard water certainly has a better taste than the soft water because it has dissolved minerals which your soft water does not have. Okay. So soft water is free from all types of dissolved salts and has a very flat taste, very boring taste. Okay. No taste is there. Now, if your salt is present in hard water, it makes it tasty. That's why your hard water is used for making beverages or wines. Okay, because of its better taste, it's used for making beverages and wine. Okay, used for making beverages and wine. Okay, now your calcium and magnesium salt that is present in the hard water. Okay, and present in very small amount in the hard water. These are very essential for the growth of our bones and teeth. Clear? So the calcium and magnesium salt act as a dietary supplement for your bones and teeth, and again it strengthens it. Okay. Next advantage of hard water is that it helps us in digestive health and constipation. So if right mixture of calcium and manganese, okay, not manganese, it should be magnesium. Okay, if the right amount of your calcium and magnesium is present in the hard water and if we drink it, it will reduce all the constipation and eases the bowel movements. Okay, so this is all the advantages that we have in case of your hard water. Clear? One more advantage is there, very great advantage, that your hard water checks the poisoning of water by lead pipes. So what happens when the lead pipes are used for carrying your water? So all of you know this, that your water is a great solvent. Yes, it's a universal solvent. So what happens during that course? Some lead salts dissolve in the water and it makes water poisonous, unfit for drinking. So if calcium sulfate, let's say, is present in the hard water, what it does, it forms a insoluble lead sulfate in form of the layer. Okay, so your lead salts react with your calcium sulfate to form your lead sulfate. That lead sulfate gets deposited inside the lead pipe in the form of layer, which again prevents the mixing of lead in the water. Okay, and thus it helps in checking the poisoning of water. So this is again a great advantage for your hard water. Clear? So these are the different advantages that we have for hard water. Now what is the disadvantages of hard water? Okay, what is the disadvantage that we face in the hard water? So basically your hard water is unfit for washing. Okay, you cannot wash clothes with the hard water. Clear? You cannot wash clothes with hard water because it's very difficult to form lather with soap. Okay, so if you try to wash your clothes with hard water using soap, you will end on wasting your soap and no lather will form, and without lather your clothes won't get washed. Scum is formed in the reaction with soap and thus your soap is getting wasted in case of hard water. If you boil hard water in tea kettles, what happened? Your furring, or you can say your damage, is caused to the tea kettles because of the formation of your carbonates of calcium and magnesium inside the tea kettle, because upon boiling your salts, that is calcium bicarbonate and all, it will get decomposed to form your calcium carbonate and that will get deposited inside the tea kettle. Okay, so this is again acting as a means damage for the tea kettle. Now hard water will also block the water pipes. What happens when your hard water goes through the hot water pipes? The layers of your carbonates of calcium and magnesium gets deposited inside the water pipes and thus makes it difficult for the hard water to go inside the pipe, and hence your electricity is wasted because more electricity is now required to boil your water. Okay, and again your pipes may burst also because the path of the water becomes narrow because of the deposition of carbonates of calcium and magnesium, due to which your water has to put more pressure and force to go through these water pipes, and hence your pipes can burst. Okay, these are the disadvantages of your hard water that we have in our day-to-day life. Is it clear? Okay, now your hard water is unfit for washing purpose. So let me explain you something. Okay, so all of you must know this, that your soap is what? This is a sodium salt of, okay, your soap is a sodium salt of stearic acid. Okay, this is the sodium salt of your stearic acid. Now what is this stearic acid? Stearic acid is a saturated long chain of fatty acids. Okay, saturated long chain of fatty acids, and your name of IUPAC name of stearic acid is octadecanoic acid. Okay, octadecanoic acid. Clear? So let me show you the stearic acid C17H35COOH. Okay, heptadecanoic acid, or it can be your octadecanoic acid also. These are the very long chains, saturated long chains of fatty acids. These are all saturated compounds. Clear? So this is your heptadecanoic acid. Now, what happens if you react like sodium hydroxide with this particular thing? What happens? It becomes C17H35COONA, and your H2 comes out. This is the soap. This is the soap. Okay, this is the sodium salt of your stearic acid, and this is your soap. So if water is hard, so the water will contain your calcium and magnesium ion. Yes or no? So if your water is hard, what will it contain? It will contain your calcium ions and your magnesium ions. Okay, so it will contain water, calcium and magnesium ions. Now the calcium and magnesium ion that is present inside the water will combine with the negative ions of the soap to form a kind of precipitate. Okay, so what is the reaction over here? For example, we have C17H35COONA, and you have, let's say, calcium bicarbonate. This is your hard water. This is your soap, and you are trying to wash your clothes with the hard water. This is your hard water. What happens over here? Try to understand. Your displacement reaction takes place, and this calcium goes and attacks on this negative, okay, this negative ion of the soap to form a very slimy precipitate, a very different, means a white type of precipitate. Okay, this will form like this: C17CH35 COO twice Ca, and your sodium will form NaHCO3. This is called as soap curd. Okay, this will come out as precipitate. This is the precipitate formed of insoluble calcium and magnesium. Okay, which is usually given the name as soap curd, or you can call it scum also. And this scum only prevents the formation of lather. Okay, prevents the formation of lather whenever your hard water is used to wash clothes using soap. Okay, prevents the formation of your lather. Clear? So your soap curd is formed over here. I hope it is clear to everyone in the class, and if any doubt is there, you can let me know. Okay, yes or no, just let me know once. Okay, chalo, very good. So this is the reaction happening between your soap and water. Now this formation of your soap curd will go on. Okay, it will go on as long as your calcium and your magnesium ions are present in the water. Clear? So till there are no soap lather will be formed, your clothes will not be cleaned, because cleaning action is not possible without the formation of lather. So these precipitates are difficult to wash off. Okay, these precipitates are difficult to wash off from the clothes. Let me write it over here. So these precipitates are difficult to wash off from the clothes. Clear? And what happens? They sometimes form rusty spots also if iron salt is also present in the, okay, if iron salt is also present in the water. Clear? So this is the problem that we generally face in case of washing your clothes with the hard water using soap. Clear? Now, synthetic detergents that are there, they are used in place of soap in domestic or your laundry places. Okay. Now, why we are using your synthetic detergents? Let me explain you. Your synthetic detergents are basically the sodium salts of your long chain alkyl hydrogen sulfate, or you can say these are the long chain of benzene sulfonic acid, like this. This is the benzene sulfonic acid. Okay. Hello Arpit, welcome to the session. Can you make videos on metallurgy of all the 4 units which are given in the concise Selena chemistry? Yes, sure Arpit. I will schedule a session on metallurgy. Don't worry, for class 10 very soon. Okay. So maybe you can have this session on Tuesday. Okay, this coming Tuesday, I can have a session on metallurgy. Okay, so do not worry about that. Clear? So I was telling that it is a sodium salt of your long chains of benzene sulfonic acid. So like this, sodium salt is present. It is a sodium benzene sulfonic acid. Clear? So how these are made? These are made by sulfonating your benzenes with sulfuric acid and then converting them to their sodium salts by caustic soda, that is your NaOH. Okay, so what happens? Let me show you the reaction. So here your benzene is first reacted with your sulfuric acid to produce your benzene sulfonic acid, and again this sulfonic acid is reacted with sodium hydroxide to produce your sodium salt of benzene sulfonic acid. Okay, so sulfonating higher alkenes, that is benzene, and then with sulfuric acid and then converting them to their sodium salts by using caustic soda. This is your caustic soda, sodium hydroxide, and these sodium salts are only known as detergents. Okay, you can see over here, this is a long sodium salt of benzene sulfonic acid. Yes, this is also a long sodium salt of benzene your sulfate. Okay, this is a very long sodium salt of your sulfate. Clear? These are your common form of detergents that we have. Clear? So the ionic group that is present in a detergent is SO3Na+. So they do not make scum in hard water. Why? Because these chains do not react with the metal ions, that is your calcium and magnesium, to form your insoluble precipitate. Clear? So detergents are more soluble in water than soap, and they are unaffected by the hardness of water because their calcium salts are soluble in water. Clear? So they do not make scum because they do not react with the metal ions to form insoluble precipitate. They do react with the metal ions, but whatever salts they produce, that is soluble in the water. So scum is not produced in case of your detergents. So is it clear to everyone in the class? Please let me know once. Okay. So is it clear? Okay. So long chain alkyl hydrogen sulfate or long chain of benzene sulfonic acid. Please do remember this thing. Okay. Okay. Chalo. And soap molecule is what? This is generally represented by this thing, that stearic acid, sodium salt of stearic acid. And in solution it ionizes to form this and this Na+, and each soap molecule will have a polar head group, that is carboxylate ion, and a long non-polar hydrocarbon chain, that is the alkyl group attached to your COO-. Now this polar head will attract the polar water molecule, and these are known as hydrophilic end, and the non-polar tail will attract the water insoluble oily or greasy dirt particles, which are termed as hydrophobic end. Okay, this is the non-polar end is termed as hydrophobic end because this get attached to your oils or dirt particles present inside the water. So whenever, what means, let me explain you the cleansing action of soap. Okay, cleansing action of soap. What is meant by cleansing action of soap? So basically what happens during the cleansing action of soap, whenever a dirty cloth, okay, soaps and detergents both is there. Whenever a dirty cloth is placed in a soap solution, what happens? As I told you, for example, okay, just let me show. C17, this is your soap. C17, H35, COONA. This is your soap. Yes or no? When it is placed in water, it breaks down to give C17, H35, COO minus and Na plus. Okay, clear? Now this the long non-polar hydrocarbon tail of soap molecule. So this is the non-polar tail of soap molecule. Okay, tail. And this is the polar head of soap molecule. Is it clear? So this is the polar head of soap molecule. This polar head will be attracted to your water particles and this non-polar tail will be attracted to your oil particles, because this is non-polar in nature. Okay. So this will form a spherical structure with polar parts of the molecules on the surface and non-polar parts will be in the center. Okay. And this spherical structure which is formed over here is known as micelle, and this micelle is attracted towards the water and it carries out the oily dirt particles also along with, and this causes the dirt particle to come out from the fabric of your cloth and your cloth becomes free from dirt in this way. Let me show you the structure of your micelle. Okay. So here you can see this is the long chain of hydrocarbons which is hydrophobic and this is water repellent. And this is the polar end, okay, which is hydrophilic or water loving. Okay. Now this in detergents case also this is your hydrophilic because this is a polar head and water is also polar in nature. So here your this will be attracted towards the water. Okay, and this is the long chain of your carbon, okay, long chain of your hydrocarbon which is non-polar in nature and it will remain in the water. Sorry, it will remain in the oil. It will stick to the oil. Is it clear everyone? Okay, it will stick to the oil. Now, here in this case you can see this is the oily dirt. So your hydrocarbon tail is coming and getting attached to it and the polar head is on the surface of water. In this way they will form a circular structure. So this micelle is formed by detergent molecules in water where your hydrocarbon tail will stick to the oily dirt and your polar head will remain on the surface of water. And you can see here that free positive Na plus ions are there. Soap solution is there. Positive and negative ions are there. And here highly negative charged micelles are there. Okay. And this is the hydrocarbon part. Okay. Clear everyone? So here you can see this is the cleansing action of soap and soap micelle has formed. So this will again take out the dust particles from the from the clothes. Clear? So in cleansing action, as I told you, a hydrocarbon tail, this is the hydrocarbon tail which is attaching itself to the oily dirt. Okay. And when your water is stirred, we stir the water na. So what happens, this oily dirt will tend to lift up from the dirty space. This oily particle will tend to lift up from the oily space and what happens, it will dissociate to give small droplets of your oil and this will give the opportunity to these hydrocarbon tails to get attached to this oil particle. Okay, this will get attached to the oil particles and other tails will also come and get attached to this oil particle. Now the solution will have small globules of oil where it is surrounded by the detergents molecule. Which part of detergents molecule? Your hydrocarbon tail of the detergents molecule. Clear? And negatively charged heads will present in the water and will prevent the small globules from coming together and forming a aggregate once again. So what is the function of this negative head? This remains in the water. Okay. This present in the water and prevent the small globules from coming together sticking together. Okay, so the charged heads do not let the micelles to come together and stick together. Okay, thus oil that is removed from the object. This is all about the cleansing action of your soap. Clear? This is how your clothes get washed when we put them in the soap solution or your detergent solution. Is it clear to everyone in the class? Okay. Now let's talk about the removal of hardness. So if anybody is having any more doubts, you can tell me. Okay, what doubt you have? Anyone having any more doubts in the cleansing action of soap and detergent, the head of soap, the tail of soap, how it is getting attached? Anyone having any more doubt? Tell me first. Okay. Chalo. So I hope nobody is having any doubt. Let's proceed back. Let's proceed with the removal of hardness. Okay. So first we will proceed with the removal of temporary hardness. Okay, removal of temporary hardness. So how can you remove the temporary hardness? So boiling is an option, yes, but if your means too much of water is present and if you have to remove hardness from such a huge amount of water, your boiling is not a very practical condition. Okay, but yes, it is a method to remove the temporary hardness. So what happens when you boil the water containing your bicarbonate salts of calcium and magnesium, which is responsible for the temporary hardness of water? Okay, so calcium bicarbonate if you take and if you boil it, what happens? It gets decomposed to form your calcium carbonate CaCO3 as a precipitate. Your water is formed and your carbon dioxide is formed. So carbon dioxide escapes in the water, okay, and the calcium bicarbonate comes out as precipitate, okay, and this can be removed from the water by filtration, or you can do the decantation also. So the filtration or decantation will remove this precipitate and your water will become soft in nature. Okay, the water will become your soft in nature. Is it clear? Same thing will happen here, happen with your magnesium carbonate also, magnesium bicarbonate also. So your magnesium bicarbonate will also boil off to give a insoluble precipitate of magnesium carbonate, which is again removed by your filtration or decantation. Carbon dioxide escapes into the atmosphere and your water is formed. Clear? But this is not a very practical method when your very large quantities of water has to be made soft. So what can we do? What is the next method of removing the temporary hardness? So to remove the temporary hardness, you can do the addition of lime. Okay, addition of lime. This process is known by the name of Clark's process. Okay, Clark's process is the name of this particular method. So what happens in this particular process? We add a calculated quantity of slaked lime. Okay, what happens in this? Add a calculated quantity of slaked lime. And what is slaked lime? This is slaked lime. CaOH whole twice. That is your calcium hydroxide. Okay. And the following reaction will take place. Let me show you the reaction. So your calcium bicarbonate will react with your calcium hydroxide, that is lime, to produce calcium carbonate and your water. Yes, calcium bicarbonate will react with calcium hydroxide to give calcium carbonate as the white precipitate and your water will be produced. Okay. So what is happening in this particular reaction? So your lime is first mixed with the water and then the reaction takes place. So your calcium carbonate settles down in the water because this is an insoluble precipitate formed over here, and after filtration this precipitate is removed and your water becomes soft. Okay, this process is named as Clark's process because Clark has invented this method of removing the temporary hardness from the water. Clear? This process is named as your Clark's method. Similar thing will happen with your magnesium bicarbonate also. So if you add calcium hydroxide to it, what happens? Your magnesium carbonate is formed as a as a precipitate. Your calcium carbonate will also be formed over here. So let me write this reaction again for you, because I think this is not visible to you. So your magnesium bicarbonate, when it is added, when calcium hydroxide is added to it, what happens? Your magnesium carbonate is formed as a precipitate. Your calcium carbonate is formed as a precipitate, and your water is also formed. Okay, these two precipitates are removed by your filtration or decantation, and you obtain your soft water. Clear? This is the two method to remove your temporary hardness from the water. So is it clear or not? Please let me know, everyone in the class. Okay. Okay. So this is the way. Third is your by the addition of washing soda. Okay, by the addition of your washing soda. So when washing soda, or you can say soda ash, is added to your hard water, what happens? Your insoluble carbonates is formed and it settles down in the water and can be removed by filtration. So this washing soda is nothing but your soda ash when it does not contain your water of crystallization. Clear? So what we do? We take calcium bicarbonate, we add soda ash to it. What happens? Your calcium carbonate is formed as a precipitate, insoluble precipitate, which can be removed from water by filtration, and your sodium bicarbonate is formed, NaHCO3. So simple, your double displacement reaction is happening. Okay, simple double displacement reaction is happening over here. Your calcium is combining with your carbonate, sodium is combining with your bicarbonate. Clear? And this way you can receive your soft water. Next is magnesium bicarbonate combining with your sodium carbonate. What happens? Your magnesium carbonate is formed as a precipitate and your sodium bicarbonate is formed. Sodium bicarbonate and magnesium carbonate as a precipitate is formed. So this is again a method for removal of your temporary hardness by adding soda ash to the calcium bicarbonates or magnesium bicarbonates, and hence your insoluble precipitates of calcium carbonate and magnesium carbonate is formed, which can be removed from the water by filtering out the water. Okay, you can remove it by filtering your water. Okay, so these are the three different methods for removal of temporary hardness from the water. Is it clear? Once again I am asking you, all of you. Is it clear to everyone in the class? Just let me know. Okay, and do not forget to like this session and share it with your friends so that maximum students can join us on this particular platform. Okay, chalo. So I hope it's clear to everyone. So next is removal of permanent hardness. How can you remove permanent hardness? Okay, so removal of permanent hardness. So to remove the permanent hardness, what we do, we take a quantity of calculated amount of soda ash, okay, and we made to react it with the calcium salts of calcium sulfate or calcium chloride, magnesium sulfate or magnesium chloride. We made it to react with that, and again your insoluble precipitate is formed, and thus your water can be made soft. Okay, so you can do, see, when you heat the water containing temporary hardness, water will become soft. Okay, so if you like have the boiling part in permanent hardness, your water cannot be made soft. Clear? So permanently hard water, if you have to remove the hardness, you need to treat it with chemicals, and that chemical is your washing soda. Okay, washing soda. Clear? Okay, so let's try to write down the equation. So first is by adding washing soda, or you can say soda ash. What we are adding here? We are adding your soda ash. Clear? So here your calcium sulfate, with this we add your soda ash. So what is the difference between soda ash and washing soda? All of you know this, that your soda ash does not contain water of crystallization, but your washing soda does contain your water of crystallization. Clear? So soda ash, it will react to give calcium carbonate as a precipitate, and sodium sulfate will be formed. Okay, simple double displacement reaction is happening over here. Okay, so this calcium carbonate comes out as precipitate. This is the precipitate, comes out and can be removed by filtering the water. How can you remove it? By filtering the water. Clear? In this way you can remove your permanent hardness. Clear? Similar thing can be done with your calcium chloride also, because all of you know this, that your permanent hardness is caused due to the sulfate and chloride salts of calcium and magnesium. So if you react it with your soda ash, what happens? Your calcium carbonate is formed as a precipitate which can be removed by filtering out the water, and your NaCl is formed. Clear? So this way you can see over here that your sulfate salt of calcium and chloride salt of calcium both can be removed by treating the hard water with your soda ash. Okay. Now in case of magnesium sulfate or magnesium chloride, what happens when magnesium sulfate is present in the hard water? You need to add a little bit of lime also besides adding your soda ash. Okay. Why we do this? Because your magnesium carbonate is not fully precipitated. That's why in that case we need to add a little bit of soda, add a little bit of your lime also. Okay. So let me show you this on the black screen. Okay. So in case of magnesium sulfate, along with adding soda ash, we need to add lime also. Why? Because magnesium carbonate is not fully precipitated in this case. Okay, so what happens? Let me show you the reaction. Magnesium sulfate reacting with sodium carbonate and your calcium hydroxide, because what is your soda ash? Soda ash is this, sodium carbonate. And what is your lime? Lime is this, calcium hydroxide. Okay, so what happens over here? This will react together to produce magnesium hydroxide, calcium carbonate and your sodium sulfate. This calcium carbonate will come out as precipitate. Magnesium hydroxide will also come out as precipitate. Okay. So your magnesium hydroxide is magnesium hydroxide and calcium carbonate both comes out as precipitate. Okay. And hence you can filter out the water and you can obtain your soft water. Clear? Is it clear? So magnesium carbonate is not fully precipitated because it is little bit soluble in water. Okay, that's why we have to add your sodium along with your sodium carbonate. We have to add your calcium hydroxides also in order to form magnesium hydroxide and calcium carbonate, which can fully precipitate out from the water and your water can become your soft in nature. Clear? So these all the methods that we discussed for removal of your temporary and hard water, all the methods are suitable at only domestic purpose. Okay, for only domestic purpose when you have to treat like small amount of water. Okay, so is it clear everyone? So if you have to treat a very small amount of water, you can have like these methods which we discussed, that is Clark's method, adding of soda ash to your for the removal of permanent hardness, and addition of soda ash along with your lime for the removal of your permanent hardness containing your magnesium salt, magnesium sulfate salt. Clear? Now if your hardness is both temporary also and permanent also, and you have large amounts of water where you have to remove this hardness from the water, you can use permuted process. Okay, which process you can use for removal of hardness of water from very high amount, means large amount of water? You can use your permuted process. Is it clear everyone? Okay, tell me fast. Okay. So let's talk about okay. So if both hardness are present, temporary also and permanent also, and you have to remove it from, just give me a moment everyone, I will be back in a moment. Okay, so I'm back. Okay, so what happens over here, your temporary hardness is also there and permanent hardness is also there. You have to remove it from large amount of water. Which process you can use? The above mentioned process are not feasible when your large amount of water is concerned. You use permuted process. Okay, which we use permuted process. Okay everyone, So again, please forgive me. I will be back in a moment. Do not go anywhere. I will be just back in a moment. Okay, so I'm back, everyone. Very sorry for the delay. Okay, so we can use here. We were talking about if we have temporary and permanent hardness both present in a water, and if we have to remove it from a large amount of water, we can use your permuted process. Okay, so what is this permuted? Permuted is an artificial zeolite. Okay, and it has the chemical formula that is hydrated sodium aluminum orthosilicate. Okay, what is the name of this permuted? Hydrated sodium aluminum orthosilicate. Okay, so if you want to write it in the form of formula, it will be like Na2Al2Si2O8 dot XH2O. X stands for that your water of crystallization is also contained in it. Okay, O8. So it contains water of crystallization also. So for the sake of convenience, what we can write it as like this. Na2P. Okay, Na2P. Is it clear? So this is the thing that we can use for large amount of water if we have to remove the permanent as well as temporary hardness simultaneously. So is it clear to everyone? Please tell me fast. Okay. Okay. So this is all the methods that we have. So what happens in this particular process? A tall cylinder, okay, a tall cylinder is taken and we put permuted in that. When hard water is passed through that permuted, exchange of ions takes place. So your calcium, your sodium comes out from the permuted compound and combines with the ions that is present with the calcium, and again calcium combines with this permuted, and hence your water becomes soft. Clear? So this is happening when you have this permuted solution. So let me show you the reaction. Just I will show you the reaction. So this is the reaction happening. If your sodium permuted is there, sorry, sodium hydrated sodium aluminum orthosilicate is there, that is a permuted. If you pass water through it, let's say calcium chloride is contained in the water, hard water through this, what happens? Your exchange of ions takes place. Okay. Hello Abhay, welcome to the session. Okay. So your exchange of ions takes place. And what can happen? Your calcium permuted is formed and your sodium chloride is formed over here. Okay. This way your water becomes soft. Okay. So exchange of ions takes place. So calcium remains with the permuted part and your water contains your NaCl and goes out of the cylinder and water becomes soft. Clear? So this when this permuted is no longer in use, you can regenerate back the permuted. How? By running a concentrated solution of brine. Brine is a solution that contains NaCl. Concentrated NaCl from this, and you can remove the calcium chloride formed by repeated washing. Clear? Is it clear? So what happens when, so once again I'm just explaining it, try to understand it. So a very tall cylinder is taken with permuted present in it. When hard water is, which is containing a calcium and magnesium ions, runs through this parts of permuted, your exchange of ions takes place. Okay, and when the ions exchange is taking place, sodium permuted is slowly changed into your calcium and magnesium permuted, and your removal of calcium and magnesium ions from the water takes place, which makes the water soft. Clear? And when you're no longer means the permuted can be regenerated by running a concentrated NaCl solution over the permuted, and you miss calcium permute means calcium P, this one. This is not your permuted. You can regenerate permuted from it by treating it with concentrated NaCl solution, and what happens again, your sodium will recombine back to this P, and your permuted can be regenerated, and calcium can be combined with your chlorine, and calcium chloride thus formed can be removed by repeated washing of the permuted. Okay, in this way you can make your hard water soft. Clear everyone? Tell me fast if it is clear to everyone. So this ion exchange is the most practical method for removing your hardness from the water. Okay. So this was all for today's session, and let me tell you about the batches. So we have champions batch, that is the all subject batch for your class 9, already started from 2nd of March. Okay Janit, very good, understood, then very good. So I hope nobody is having any doubt, and if you have any doubt you can tell me. So this is the batch, these are the teachers which will be taking your classes for students who are going from 8 to 9, and a batch is also starting for all the students who are going from 9 to 10. Okay, so you can join this batch also starting from 16th of March. And if you are not sure about taking the subscription, you can simply download the Unacademy app, watch all the special classes, and to unlock the special classes you can use my code, which is absolutely for free. Your special classes are absolutely free. Do watch them and then make up your mind that if you have to take the subscription or not. Okay, so this was all for today's session. Thank you so much for attending the session. Do share it with your friends. Do not forget to subscribe to the channel and like the video. Do not forget to hit the bell icon also. So next session will be on Monday. So tomorrow we won't have any session on YouTube. So till then, bye, thank you, and take care everyone, and all the best to everyone who are having their examinations. Okay, so bye once again.